Welcome to episode 8, Lacking Adventure. This is Kel with you today, and today I'm going to be talking about computers, really. This is not going to be anything real gaming related. I was asked a long time ago to help with someone who was really confused on basically what is the basics of a computer. And I wrote up a forum post that was long and most people probably didn't even read it. But the people who actually needed the info hopefully did. And I was told to put it up somewhere. So I'm going to put it here. So here we go. We're going to start off with the main thing that does the most in your computer, the thing that actually makes it a computer. And that's the CPU. Often seen like this. The other side tends to be flat for Intel CPUs right now. There are other CPUs that have like little pogo pins on the other side. Just basically look like gold sticks sitting at the back of the CPU. Unless you're building a computer, you're never really ever going to see it because it gets plugged into the motherboard and is covered by a heatsink. And I'll show you the image of the heatsink. Nope, I'm not going to show you the image of the heatsink. It's basically a big box that gets thrown on top of it, and it helps to dissipate the heat. Because these things actually do get quite hot. Notice the silver cover on it. It's also a heat sink. It's a plate that will help to spread out the heat that the CPU actually generates, and then it'll get pushed upwards into the heat sink and dissipated out so that the CPU itself does not overheat. This is the heart of the computer because everything that it has to do when it comes to any kind of complication, mostly moving data around or adding values, subtracting values. I'd say multiplying and dividing, but those are really just successive, addition and subtraction. So everything that goes through it, and checking my notes. Best tip for this, for which ones you want to buy. So if you are going to just build a computer to do basic processing, like, I'm going to write an email to somebody, or I'm going to go check the internet, or, I don't know, make a PowerPoint presentation and make a video off of it, you don't need the best CPU out there. You can buy the middle-of-the-road processor, and it's basically the ones you'll see for anywhere from $100 to $150 if you're building your own. You don't want to go and buy a processor that's out there for $300, $400, $500, or $1,000 because you don't need it. And of course, within a few months, those prices will drop when the newer models come out. So for the most of you who don't need the up-to-date speed every single second, don't go expensive. Next thing is the memory. Often looks like this. Sometimes you'll see a silver plate over each side. Those are actually, again, those are heat dissipators. So basically the heat that builds up on each of those black modules on there will get dissipated out onto the plates, and then the fans will brush air across them, at which point the heat gets picked up and moved away. So the memory is basically like a giant staging area. Everything that goes through the CPU ultimately waits inside of memory. It's also known as RAM. It is just the letters RAM, also known as random access memory. And that basically is everything. So if anything that you are using, any program you have open, is existing in memory in these chips. It's also very fast, which is why whenever you open a program or you're messing around with a document, you move quickly. You don't have to worry about the computer. You don't hear the disks moving around. It's because it's not accessing the actual disk. It's all working on these chips. Obviously, the larger the memory, the more you can do. So if you're running, say, Windows 7 right now, the minimum you're going to need to run Windows 7 is around 2 gigabytes. I'm not saying if you don't have 2 gigabytes Windows 7 won't load. It will. but you're not going to get really an optimum experience. I mean, it's going to be you'll get you'll lag spikes, you'll get things won't move around very easily, you'll get hiccups, and then you're going to get, and I don't know if that got blipped in, I'm getting messaged apparently. So basically, my spot in here again. If in the event that a loaded program is larger than memory, then it's going to load only the partial of the program, only what it really needs to. But it also means anytime it goes and says, hey, I need some part of that program, and it's not loaded in memory, it now has to go to the hard drive. And that takes considerably longer. Granted, we're talking microseconds in speed, but it's considerably longer when it comes to, how long it takes to access the hard drive, gather that data, bring it back, place it into memory, and then allow the operating system to actually use it. So if you have larger amounts of memory, you're less likely to ever run into that particular position. And that pretty much sums up the memory. Next up is video cards. It's what every child and gamer dreams about. Without it, most of the things that they want to do, they can't do it. Of course, without a video card, you couldn't even use a monitor. So the video card itself is what everything goes through. So the computer has to have some kind of a video output, which in this case is a video card, that will output to a monitor. And the better the video card, the better the picture. But with the advances in technology, if you're just using the example of Office or the internet or email or any of those, you don't need a lot of processing power. With advances in technology, even the worst video cards, often built in to certain motherboards, are well more than enough. If you want to actually play video games, these video cards also potentially are enough to play. Now you end up playing on the lowest of settings for some games, depending on how new they are, and I don't know about you, but I wouldn't be satisfied with that. Video cards themselves, these external cards, and I say external because they're not physically attached to the motherboard. They can be swapped out. They are actually really required in order to get a really optimum experience when it comes to playing a lot of games. Now, one thing you'll see on motherboards is that they've got memory attached to it. You'll see, oh, this is a brand new NVIDIA GT or 680 GTX with 2 gigabytes of RAM on it, and it's DDR3 RAM. And really, what does that mean? If you've got 2 gigabytes of RAM on your video card, what about the RAM on your computer? Now, I've got 16 gigabytes of RAM on my computer, and I got a video card that's got 2 gigabytes of RAM on it. What does that mean? What does it mean? I have 18 gigs of RAM? No, it doesn't. Basically, what it means is the video card realizes what it's going to work on. So when it comes to loading a game or playing something that's really huge, it's going to load as much of it into places where it's going to be most efficient. And what that means is that if you're playing a video game, the images most often used are going to get stored in RAM on your video card, so that it can offload a lot of pressure from your system onto the video card. And this ultimately helps in game speed, as well as the computer being able to function better if it's multitasking. I know I'm often playing a video game, watching a movie, messing around with files, I'm programming, whatever it is I want to do at the time. I'm often multitasking, doing more than one thing at a time. And this helps significantly in trying to make sure that works without bogging down your system. Well, this is the sound card. Most of you have never actually had one of these because they're not really required. I know I've had one forever. I bought one probably 8 years ago, a Sound Blaster X5, and I've been using it ever since because it gives great sound, and I've never had to replace it. But what is it really for? I mean, obviously, without a sound card or any kind of sound ports in the back of your computer, you get no audio. So that's the easiest one. You get no audio whatsoever. You can't use your microphone, you can't do any of that. So these obviously have the ports for your microphone, any speakers. The complicated external ones here, this one has 6 ports on it plus a port on there I don't recognize at the moment. I think it's maybe Firewire. Maybe, I don't know. Basically what that you're looking at is going to have a line in, which is basically like if you've got an audio device and you want to plug it in, you can plug it in there. It's also going to have an input for your microphone. It could also potentially have, if you're going to have, say, 6 speakers, a 6-speaker computer desk system. I know I only have a 2-speaker system because that's all I need. But if you decide to have a 6-speaker system, it could potentially have a port for every single one of those, including one for, say, the bass, because it's the big box. If you want more on audio stuff, look up something on audio speakers. It's not going to be here. Anyways, the sound card itself. Now, is all sound the same? No. It's kind of like if you get a deck for your car. You know, stock systems, they get by. You get an upgraded one, you suddenly realize, what have I been listening to? It sounds so much better. Now, some people say vinyl is good, but CDs give a pretty good sound. Is VHS better than DVD? No, DVD's way better. Is Blu-ray better than DVD? Yeah, Blu-ray's better. Way better. Because the quality's so much higher, you can output so much better sound. And this is what's happening here. The external, the better the card, the better the sound that gets outputted out. And the speakers will play the better sound. They just play whatever it's given. If you get a really good sound, you get a really good It's redundant. Anyways, moving on. That works pretty well. The hard drive. So this is the internal version. I can tell because you see the disk. The disk itself is a good representation of the disk because it is the disk. It's pretty much where your data is stored. It's on the other side though. It's not like you could open it up and scratch it or look at the back and scratch it and you wouldn't get anything. Sure, I wouldn't recommend actually doing that, but this is what the actual disk would look like. Not all versions are the same, obviously. Every vendor has their own particular style. Basically, the hard drive, what do I have written here? It's where your data is stored. When you turn your computer off, where do you think it goes? Well, it gets stored here. Done. This is where it is. When your computer boots up, it's pulling all the information it needs to run your operating system from this disk. So obviously, the larger the drive, the more data you can store. Nowadays, there's no point getting less than 500 gigabytes for a desktop system because it's so cheap. I don't remember how cheap it is now, but I went out on a whim and bought a terabyte drive. It's really not that expensive. So the other part of the hard drive is accessing speed. There are two different main types of hard drives at this point in time. One is the hard disk, seen here. The other is the solid state. And solid state is different because it really doesn't have any moving parts. A solid state drive is more akin to the memory disk we saw earlier, where it's basically taking those black modules that exist on the memory disk and aligning them in a sort of way where it sort of is just a giant box full of memory. Now it's going to have a lot less space in it right now because the technology is still fairly new, I guess. and the sizes will be smaller, and the drives themselves will be more expensive. You're probably looking at for lower prices, you're looking for 150 gigabytes. Will probably get net you about $130. Now, granted, that will change. It will shrink in price as things become more available, and prices and of the materials needed to build these get cheaper. For the disk drives, the main stat on them are the speed that the disk spins. So just like when you played your CD players, they spun around in order to be viewed. Well, the discs do the same thing. It's the main noise maker in the computer. When you hear it start ramping up, it's the hard disk. It's this hard drive spinning around, and they go anywhere from 5,400 RPM, which is revolutions per minute, to 7,200 to 10,000. Now, 7,200 is really the fastest you really should be going. 10,000, really not worth it. Not really needed. 5,400 is fine. It's quieter. But if you want a more high performance, push it to 7,200. And the price difference is negligible. So choose whatever fits best for the computer that you are looking at. There is one other part to the hard drive in that this is called the internal. Well, if this is the internal, this one is the external. That's what most people have actually seen a lot more of. The internal ones are stored inside the computer base. This one is the external drive. You pick it up and you walk around with it. Granted, I wouldn't recommend throwing it. Wouldn't recommend dunking it in water. It's all the same as everything else. It's plugged in by USB port, FireWire port, whatever it is set up for that particular hard drive. But it's basically the same as before. The disk, it's the same look, same feel inside, but it's covered and it's made so you could be transportable and easy. So you can pick it up, you can take it to another computer, you can plug it in, now you have access to your data elsewhere. Other than that, the rest of the deals stay the same. This is your optical drive. Like they used to have CD drives, which are now obsolete. Now they have DVD drives. Now with the advent of Blu-ray and the previous version, which was, or the previous competitor, which was the HD DVD, which I don't believe exists anymore, they'll each have their own drive. Now there's usually a read version and a write version when it first comes out. Notice on the edge of the disc here that it says RW, means to read write. So if you see one that just has an R on it, or an R on it, then it's a reader. So basically you put a disc in, you can read whatever's on it, you can watch whatever's on it, doesn't really matter that. But if you ever want to actually write a DVD, say you like to make CDs for your car, or you wanted to make a DVD of a video to send to your friend, or you wanted to burn a bunch of data and back it up onto a DVD disc. Can't do it unless you have a read-write version. They get cheaper as the models are out longer, so Blu-ray right now should have a read-write version that's fairly cheap. Granted, I don't know the price of the actual Blu-ray discs at the moment. Those may be more expensive. Not that much expensive, but more expensive than DVDs. I'd show you a picture of a floppy disk, but do you guys even know what a floppy disk is? Yeah, I didn't think so. So, what else we got here? Oh, what is this? This is the wireless card. You can tell by the little black tail here. But the idea is this is going to pop out the back of your computer, and it's going to be the signal receiver. So that your wireless router you have set up will transmit a signal, and this will catch it. And it will communicate back and forth. So that you can connect to the internet wherever your computer is. So, what's the deal with this? Notice it's plugged into your motherboard using one of your slots, and I don't really want to get that complicated. So, basically, if you want to have this computer in your room and have the wireless modem, excuse me, in the garage, then the only way to connect it, unless you're going to wire through the house, is to have a wireless receiver like this, talk back and forth. And that's the easiest thing. So let's move on from there. Alright, now we're on to the brain. Well, I guess not the brain, it's more like the skull. If the CPU is the brain, this here is the entire thing that puts it all together. So even if you have the brain, without the rest of the body, you ain't going to do anything. This connects it all together. So there's a lot of stuff written on here, and you can look at it on your own. I just pulled the image from Google. I pulled all these images from Google, really. But the motherboard, this is the one thing, if you're going to spend a lot of money on something, this is the thing I would say. Yes, spend your money on this. Don't buy a cheap one. Don't buy the one that's dirt cheap and you're like, oh, I can get by on the motherboard. It's not that important. It really is. Now, motherboards, they have a bunch of wiring on this board. This is not just, blue board that people like to draw on. Notice these right here that look like little batteries. They're like little capacitors. They're just little things that, well, I'm not getting too technical, but it's basically, there's a bunch of wiring all over this board, and it connects every single one of these. And if you have a poor one, you may get poor wiring. You may get poor sockets. You may get damage. Like the boards themselves may not be as sturdy, which means if you give it any kind of pressure or the wrong electrical current goes through it, it may actually crack. And you don't want that. You don't want anything else like that. You don't want bad software. The motherboard comes with its own software base. When you turn it on and you see the screen that says, "Oh, you've got a terabyte of drive space," and I'm checking all your drives, and it's checking your memory. All of that is from the motherboard. And you get a good system, you get better software, you get better components. I fully recommend getting a good one. Granted, you don't have to go above and beyond and spend $500 on it. But don't buy the one that's $25 or $50 or $60. Buy the one that's in the 100 to 200 range. Also, you want to make sure that you get a motherboard that fits what you're getting. So if you get a PCI video card and you have an AGP video card slot here, you can't fit it. You end up having to use one of these PCI slots and you get a wasted spot. Make sure that you get a video card that matches. Make sure you get the CPU that matches the right socket. Now, if you ever build one, you need to know that the CPUs have different socket types. And every socket type has a different set of motherboards that are available to it. So keep that in mind. You also need to make sure that you have enough connectors for your motherboard to your optical drives, hard drives, whether they're connecting by IDE cables, which is the gray cables that are connected to the, they end up getting connected right here, or by USB slots. USB connections are a little bit different on here, but they do exist, and they take up very little space, kind of like over here, I think. Be an older board, but something else to think about. Everything has to tie together, and this is what it needs to tie together with. Also, you could have a video card plugged in. Let's see if this one has one in here. I'm not seeing one. So this one doesn't actually have a video card built into the motherboard. Some of them will. If you don't want a video card to buy one, make sure your motherboard you choose has a built-in video. Then, otherwise, you're going to be having a built computer with no video, and you can't. It's a useless machine at that point. So, make sure you keep it all together, and tie it all back in. So, hopefully, this has been not as much of a ramble, and informative and helpful in some sort of way. And, well, hopefully we'll get another video out there eventually. Have a nice day.